Howdy PreCal, it's Miss Kosh. We are now continuing. We started, where did we start? With this page. And this is video number 3. The last video was this page. And here we are on this page. Now we are talking inverses. Okay, and so one thing that we often get confused about is kind of notation. Okay, so I'll talk about that as we go. It says given, well, and once again, I'm not going to do everything, so if you want to go look at my answer key, that's a great idea, but anyway, there's just too much. Okay, so is f of x a function? Yes, this passes the vertical line test. This little piece right here, for every x value, there's exactly one y. So is that, yes, it's a function. Is its inverse a function? Well, to find its inverse, we switch its x and y's. And it's also a reflection over the line y equals x. Well, so this is the point -3, 0. So to find its inverse, I need to do 0, -3. And then I would come up here. This is the point 0, 3. So I would need the point 3, 0, which is over here. And you'll notice, and then this is the point 3, 0. So I need the point 0, 3. So its inverse would be this. Okay, so basically I've taken this one circle and I've reflected it over the line. This is the line y equals x. And that's how we know that they're inverses. So is the inverse a function? No. Okay. However, if I said to you to graph f to the -1 of x, this is function notation. So what we would have to do is we would have to restrict this whole thing so that it's now a function. Notice it fails the vertical line test. And so if we wanted, so f to the -1 of x would be just this piece of it. Okay, excuse my coloring. There's a reason I don't teach kindergarten. But this piece, or art, but this piece of it would be the piece of the inverse that makes the inverse stay a function. Okay, so this function notation implies that your answer has to be a function. Okay, so, but they're not asking that. So now they're saying the domain of the inverse. So what's the domain of the original one? It was from -3 to 3. What was the range of this guy? From 0 to 3. So this new one, they didn't say domain of inverse function. They just said inverse. So the domain was 0 to 3. And the range of the inverse is going to be -3 to 3. And notice these match going that way. So if you think about it, that would make sense. When we switch our x and y's, that means our x's with the domains become the y's with the range on the inverse. If I said, what's the range? If I asked, what's the range of f to the -1 of x, you would tell me that it's 0 to 3. Because we would have had to restrict it to the piece that's a function, and then there's its range. I'm going to skip this one, but you can go look at my answer key. Okay, so in order to prove algebraically, so this is how we do an algebraic proof. We have to show that f of g of x is equal to g of f of x, and they're both equal to x. Sorry, I ran out of space. I did not plan that properly. Okay, so on this one, I can do f of g of x, which would be equal to, oh, I should have used my green. G of x is in green. Sorry, that got messy, but you're fine. So this is 3 times something minus 1. That something is the 1/3 x plus 1/3. So when I clean this up, I get that this is 1/3 times 3 is x, and then plus 1 minus 1. Oh, look, that equals x. Okay, so that's good, but we are only halfway through our actual proof. So now I have to do g of f of x, which would be equal to g was 1/3 times something plus 1/3. That something was f, 3x minus 1. Distributing through, this is x minus 1/3 plus 1/3. Notice they cancel out. We're left with x, and this is an algebraic proof. Okay, so they're giving us these two, and they're saying, oh, are these inverses? Well, let's check and see. So f is 3 times something plus 3. The something was -1/3 x plus 1. When I distribute, I get a negative x. I get a positive 3 and another positive 3, which is equal to -x plus 6, which is not equal to x. So the answer is no. Okay. Continuing. Okay, we've got this parabola, and I wrote it this way to remind you how to complete the square. I did that on purpose. So what I'm going to do is come down here and say y is equal to x squared minus 6x plus a box plus 1. So all I've done is add a random box in here so that this can become a perfect square. But if I add a box, I either have to add a box to the other side, or I have to subtract a box, so in essence, I'm adding 0. Because if I add 0, nothing changes and all's well. So what I've done is I've said plus a box minus a box. Keep in mind, if this had been like a 2x, then I could factor out the 2, and then I would have 2 box and a 2 box. Go watch my other videos if that didn't make sense to you. Okay, so now this part right here becomes x minus 3 squared. So, because half of 6 is 3, and the negative stays, so 3 squared becomes a 9, and then when I subtract, I get minus 8. Okay, so find the inverse. Now what I want to do is I want to switch my x and my, so if I wrote this in the form x minus 3 squared minus 8, whereas this is going to have a vertex 1, 2, oh my goodness, you guys, my eyes, don't ever get old. 1, 2, 3. And then I'm going to go over 1 and up 1 in both directions, and I'm going to go over 2 and up 1, 2, 3, 4, and then back 1, 2, 1, 2, 3, 4. And then I'm going to go up over 3 and up 9. I was at negative 8, so that should put me here and here. Oh my goodness, don't ever get old. I don't recommend it. Okay. Here's this. Okay, so there's our parabola. So when they say find the inverse, we need to switch x and y. X is equal to y minus 3 squared minus 8. I'm going to add 8. I'm going to take the square root of both sides, and I'm going to add 3, and then that's how I get f to the negative 1 of x. I'm sorry, I did all those things at once. But so the domain of my function f is all real. But if I took the inverse of this, I would go from here to something like this, which is not a function. And so I'm going to have to restrict the domain in order for its inverse to be a function. So my inverse is where I'm going to come, I have an x at negative 8 and then a y at positive 3. So I'm here, and then I go up 1, I go 1, 2, 3, 4, 1, 2. And then this was the point. What was this point? This was, what is that? 1, 2, 3, 4, 5, 6, 1. So I need to go 1, 1, 2, 3, 4, 5, 6. So that does fit what I had. So notice this piece right here, if it were reflected over the line y equals x, becomes this piece right there. Okay, so the range of this guy, how low did it go? It went as low as negative 8 to infinity. So now this one, its domain goes from negative 8 to infinity, because notice this, we can say x plus 8 has to be greater than or equal to 0, so x has to be greater than or equal to negative 8, because you can't take the square root of a negative. If you do, it's no longer real. The range is going to go from 3 to infinity, which is the piece here that I would have restricted it to. But now be careful how they ask the question. If they say, what's the domain of f? You have to tell me, based on f, what's its domain? The range of its inverse, you know what? I want to change these directions. Let's say the range of the domain and the range of f to the negative 1. Okay, so we want to indicate that I am looking for the domain of the inverse function, and that's what we need to say. Okay, on this one, I'm going to change this right now. F to the negative 1, f to the negative 1. Find the inverse function. Okay. So on this one, I'm going to switch x and y. X is equal to the square root of y plus 4 plus 1. Subtract 1. Square both sides. Now we're going to subtract 4. And so the inverse function is f to the negative 1 of x is equal to x minus 1 squared minus 4. Okay, so this domain shifted me to the left 4. So it's negative 4 to infinity. You could also think, okay, x plus 4 has to be greater than or equal to 0. Subtract. That's going to be x has to be greater than or equal to negative 4. So we are at negative 4, 1, 2, 3, 4, positive 1. then I'm here, and then back to, okay, and so we're doing something like that. I should have graphed more points since they gave me a grid, but whatever. Okay, the range, I started at +1, I went to infinity. Now, here's the trick on this one. When I look at this function, if it came by itself, if I just said, what's the domain of a quadratic, you would tell me all reals. But this is not asking me for the domain of a quadratic. It's asking me, what's the domain of the inverse? Well, the inverse, this is one, the inverse only had one arm. So if you could see me pretending that I'm standing up there and this is my one-armed swimmer, and I'm standing there with one arm. When I go to find its inverse, all I get is I get 1, -1, 2, 3, 4, and then I have this, and then I have this, and so I start doing that. It's a piece of that parabola. And I like to say in class, I don't get to grow an arm, okay? So since this is all I had to begin with, the inverse only has that. So if I have one arm, and I go to find its inverse, it's something like this, or I can't really show you with this video, but it doesn't get to grow an arm. So the domain will be 1 to infinity. Now there's a difference if I said, what's the domain of a quadratic? Well, the domain of a quadratic standing on its own is all reals, but this is not a quadratic standing on its own. It came from this original function here. And so its domain has to be based off of the original function. The range of this guy was from -4. That one would be the same even if it came first or not, but there we go. So be careful with that. One last problem, and I'm going to, okay, so x is equal to y minus 4 over y plus 2. I can think of this as over 1, and I can cross multiply. So I have x times y plus 2 is equal to y minus 4. I have xy plus 2x equals y minus 4. Let's get everybody with a y to one side and everybody without to the other. Xy minus y equals -2x minus 4. Notice I can factor a y out of both of these. And now these are multiplying, so we're going to undo that with division. Okay, so the inverse function, well, we should say find f to the -1 of x. We can say f to the -1, f to the -1. Okay. Find the inverse would be equal, f to the -1 of x would be equal to -2x minus 4 over x minus 1. Okay, so now let's see. This one, if you think of the domain, you are not Chuck Norris. You cannot divide by 0, so x cannot equal -2. So our domain is going to be from -infinity to -2. Pick it up again, -2 to infinity. Okay, our range, this, if you think about it, we have a horizontal asymptote. This was same degree. So 1 over 1 is 1. So we had an asymptote of x is equal to -2. We had an asymptote of y is equal to 1. So my range will be everything except 1. So from -infinity to 1, pick it up again from 1 to infinity. My domain of the inverse, here's the inverse. Well, this, it had better be that. But let's check with what we know about rational functions. You're not Chuck Norris, you can't divide by 0, so you would go from -infinity to 1, pick it up again 1 to infinity, which matches exactly. The range, divide the leading coefficients. We have a horizontal asymptote at -2, so the range is -infinity to -2 to infinity. Do you have to think through this one the same way? No, but it helps you know if you made a mistake. If these don't match this way, then you know you've messed up. Okay, I think the rest of this is all extra practice, so good luck. Let me know if you have any questions.